What's up, everybody? So my next kata I'll be doing is odd march bits. Odd march bits 8 bits. It's a weird name. But anyways, I've had a pretty good time solving this one. Took me a while actually. For a 7, it's kind of difficult, but I mean, it was an interesting one. I think this is a pretty new one, so it doesn't have a lot of like solutions. But I actually did this one, retrained with this one a couple times. My first solution was super convoluted. I'll show you in a sec. But yeah, we'll just go ahead and read the instructions. So odd bits are getting ready for bits battles, and this is like another, like more katas, links to another more katas in this series. Therefore, the in bits march from right to left along an 8 bits path. Once the least significant bit reaches the left, their march is done. Each step will be saved as an array of 8 integers. Return an array of all the steps. I is going to be, or in is always going to be in between 1 and 8. Or not between, but it's going to be equal to 1. Or it's going to be the numbers from 1 to 8 is basically what this is saying. And then in is never going to equal 0, which is nice. So basically, as we can see from the examples, we're going to take like in, which will produce, this is telling us how many bits we have that are going to be starting on the right. And then we're going to take the necessary steps to move these 3 bits one by one all the way to the left. Let's see with this one, we've got 7 bits in this byte, and that's being moved over like that. Just to be clear what we're talking about, in binary, 1 digit is a bit, and 1 digit is a bit, so that, and a byte is 8 bits, I think, right? So if we move all the bits over, we're doing this, where we get this new number here. Okay, so to make sure we're returning, I'm gonna just set up our main return here, so we don't get, I always forget this step. But so I want an array of steps, or an array called steps, to contain my steps. I'm gonna initialize that as empty. Okay, so now we know that we're returning something. We're not forgetting that step. So what we're first going to do is, I want a placeholder, or I want to initialize this with 1 array inside of it. And I'm going to be using this first example, to work off of. So if that equals 1, we want to return 1, 2, 3, 4, 5, 6, 7 zeros, and then a 1 for the first one. And we want to return this for the second one, not for the third one. I'm not going to do the whole thing at once. I'll like console log the steps as I do them. So we want to calculate the numbers of zeros that we need. I'm going to make a variable for that. So zeros is going to equal like 8 minus in. So the maximum this can be is 7, right? And in this example, it is going to be 7. So what I'm going to do for this, I'm actually going to use the forbidden array constructor using like an spread operator to make my array. My arrays are always going to have a length of 8. So that's what that is. And so what this is going to return is an array filled with 8 items that are all undefined. So what I'm going to do is map over that array, and I'm going to take each, so take each item in the index. And what I really don't need the item variable, or the item parameter, I just need the index parameter. So what I want to do is, as this is incrementing through, I want to enter a 0 for all of these until the index goes over a certain amount, and then it'll enter ones, that is. So, or that would be 0. So this index right here would be 6, right? Because we're starting at 0, going all the way, it's 8 long. So if it's longer than 6, I want to return a 1. Okay, so if I, as long as I is less than 0's minus 1, I'm going to do a ternary here. So as long as I is less than 0's minus 1, I'm going to return a 0. Otherwise, we'll return a 1. And then that will be our first value there. So we can see the results of that. To the left here. Okay, so we've done a bad. So we're printing like 2 of these. We just need to adjust our value right here. And that's what we want to see from the first example, which is it's this test being run the first time. Right? So that's consistent with that. Okay, so, but what about the other steps? So we need a for loop. And since what we have right here is 1, 2, 3, 4, 5, 6, 7, total of 8 steps here. Here we have 7, and here we have 6. So you can see it's the same pattern as, like, it's a similar pattern to the zeros, right? So since we already have this array made, all we need is 7 more. So we can just use our zeros value for our for loop as our limit, right? So I'm going to start this on 1, which is going to be important later. So as long as I is less than the value of zeros, which for the first test is going to be 7, we're going to turn I and increment that. Okay, so what do we want to do? We're going to be pushing arrays to steps. Okay, so how are we going to generate these arrays? What I'm going to use is the reduce function. So the reduce function is, it's called reduce. So it's often used to add numbers together, but you can also return functions with it. It's very useful for that kind of thing. Suppose I could use map, but reduce is cool. You'll see. So, but what array are we going to use? Are we going to be mapping over with reduce? We're going to need to generate. Well, we just need, since we already have this array here, we can just use this. Well, that's the only one we can use, I guess. That's, what we used to step through. So we take, well, we want to use the last one, so the one before. So we're going to do I minus 1, and that's going to be our array for the reduce. We're going to take, so to reduce, so to do this, we need like 4 parameters. We're going to use, let's call this the byte, right? So we want to generate our byte as an array. That's the array we're generating. And then taking the current bit, we need the index of the loop, and then we need the array that we're looping over, which we're calling last step. The array that we're looping over, that's last step. And then after our callback, I'm going to define just a default value for the byte for what we're returning. Okay, so I guess we don't need these parentheses. But what we're going to be returning is an array, right? But I'm going to use spread operators here. So what we want to do is return the previous value of byte, which is what this is, so we can, you know, accrue values over time, right? And we want to make sure they're being put into this array. And what we want to add to this array is either a 1 or a 0, based on, so what we want to add is a 1 if in the past there was a 1 in front of it. So we want to take that last step and say if ahead of this location there was a 1 in the past, we'll put a 1 at the current location, right? So what that would look like is I take the last step and I'm going to take the I and add 1 to it, right? So that's going to be my, I'm doing a look ahead behind, I'm doing a look ahead right here. So that's, so if we're here, so we've already generated this, right? And now we've generated, we're going through and we're generating this one. So that'll be a 0 because here, that's a 0. That'll be a 0 because here that's a 0. That'll be a 0 because here that's a 0. That'll be a 0 because here that's a 0. And so on and so forth. But when we get to this one, this will be a 1 because that one's a 1. Is what is our desired result. So we're going to put this step into a ternary, right? So if this is truthy, means it's a 1. So if that's truthy, we want to generate a 1. If it's not truthy, we generate a 0. And that should work. It does not. What have we done wrong here? Well, I can't clearly see that. Done something wrong here. Okay, so it's not doing enough steps. So to add on that last step, I need to do this. Because it's looping up and it's getting up to 7 and it's stopping without doing that last step. Rookie mistake. But now it should work. And we're gonna attempt that one. And that worked. Okay, so I want you to see my first solution, which is basically this, but with more steps, and like way more convoluted. So instead of just defining this here, I've defined it to go off on like the zero go off on the zero index, but I realize I can just start at 1 and put that there, and then it's way less space. And then like all this code is just doing what this line does, but I've sort of condensed it down. I think this is a bit easier to understand. I'm not sure, but I think this is a bit, well, maybe this is actually more readable. I'm not sure which one. I think if I was writing like a whole like big project, I might go with this code over this code. But this is Codewars. We're trying to make it nice and short. And I would recommend looking through these other solutions because they're probably better than mine. All right, I'll see you next time.